Revit has a nice tool for making shop drawings, component drawings, kind of automatically, and it's called assembly drawings. And the reason I'm talking about component drawings is on a big building like this, a lot of your stuff is or a lot of the materials are going to come probably from a factory, and it's probably going to be made off-site and then put together on-site. So it's a good tool to have. So what I'm really talking about here is level 4 on the SFB table, the component level, before you get to detail level and beyond the level of plans and sections and elevations and so on. So this is when you decide on the procurement type of your elements, and then you need to make a drawing to send out to make sure that they get made correctly and so on. There's also this nice, where are we here? This one here. The A113 specification, which is also dealing with components, specifically concrete components. What I'm going to do is a drawing that's something like this, and then when you make a component, then you need to know where to put it. So really that's what it's about. So you have a drawing like this, and then you have something like this with a code number that tells you where it goes on the plan. And if you have those two things, they know how to make it, they know where to put it, and that's pretty much 95% of the problem. Okay? So we can get Revit to do that automatically for us, which is nice. So I'm just going to take you through how we do that. So I'm just going to shut this down. I'm going to take it from scratch because I've just done it next door. Shut down, shut down, shut down, shut down, shut down. Let's do it the quick way. Shut down. All right. Now, oh God, it just keeps going. Okay, so what I'm working on is that you start off when you're making a building, you make an architectural model which takes care of all the spaces, the dimensions, the heights, all those main things that are supported by the building regulations. You can take it further and make a construction model. And we started to do that last time with making the static elements, the structural elements of the model. So we can continue with the structural model, and we can actually use the architectural model as the basis for making any prefabricated elements as well. But I'm just going to do it kind of in a vacuum just to show you the principle of it. And I'm going to use as an idea. I'm going to make a simple wall panel like I was showing you there with a window in it, and I'm just going to show you the techniques of how you turn that into a component drawing. So the first thing, just going to start off by drawing a wall. So let's just draw a wall at 90 degrees like this, and it's just a basic wall because I want to set up the panel. So if I go to, first of all, to see what the elevations are like, just to have them set up correctly, let's make sure that our level is set to 3.6, like that. And now we can also set the top of the wall to its unconnected height to 3.6. It's very important you set it to unconnected, because if you connect it to the level, then you can't move it around. It'll always try and connect itself to the level. So I'm going to leave it unconnected, and I'm going to make it 3.6. Apply. So then we have something like that, and I'm going to make it, let's say we've decided to make our panels 4.2 meters long. So now we've got the basic shape of the first panel that we want to make. So now I'm just going to go into it, and I'm going to remake the wall, edit the type, duplicate it, and we'll make a new panel wall build up, and going to edit the structure until we get all the layers we want in there. So let's start by putting in an external finish 1. We're going to give it a thickness of 150, and we'll make the external finish, we'll make it concrete broom finish. Then we're going to put in some thermal layer. I'm going to make that 200, and I'm going to make that just insulation. That insulation. Then the structure I'm just going to make as precast concrete or something, just as an example. Concrete precast. Okay. And then I'll move this down, and I'm just going to turn that into finish 2, and I'm going to make that gypsum wallboard. So I've got a wall that looks, concrete needs 200 millimeters, and gypsum needs 12.5. So it should be something like that. Okay. I'm going to press OK, and OK. Let's just turn on the shading view to see if we can see the difference between the two sides. Okay, so they're kind of, the concrete is grey and the plasterboard is a little bit white, so at least we know which side is which for the moment. Now, usually with if I just make a section through that, I've got a level 1. Oh.
Thank you.
No problem. If I go to level 1, I'm going to make a cross section through the panel, and I'm going to go into the section. And at the moment it's just one of those simple walls that Revit makes. Just change the scale to 1 to 50 here. So we have concrete, we have insulation, and we have the concrete, lightweight concrete on the outside. I want to make a tolerance around the edge, and I also want to mold the edge because it's a concrete panel and it's usually not completely straight like that, because you need to be able to get your hands in there and seal it up and all that kind of stuff. So there's usually some kind of chamfered edge on a concrete panel, and we want to be able to get in there and have a look at that. So let's just change the scale to 1 to 10 or something, so we can really get in close without everything being screwed up. So I'm just going to draw the shape of what I want the tolerance to be. And I mean, when you're designing components, you usually have 2 levels of tolerance. You've got tolerance for the shop, like the guys who are making it in the shop, they have a certain tolerance they have to work to in order to make sure that it's close enough, and it's usually 10 millimeters or something. You can find all tolerances on toleranza.deco. Put it through Google Translate if you have to. You also need tolerances for assembly on site, because if you're lifting these things up with a crane and you have to put them in place, and you need a tolerance. So you're not trying to make it millimeter perfect every time, because it's never going to work. So let's put a tolerance in here of 10 millimeters, and I'm going to also put in a chamfer on the wall here. So I'm just going to use the annotate tools, detail lines. I'm going to draw a line along the top, and I'm just going to use the offset tool to offset it by 10 millimeters to that side. Let's make another line. Let's say we're going to make a line from 60 millimeters in, and we make it at 135 degrees, like that. I'm going to trim those together. TR is the shortcut for trim. And now I'm just going to finish it off so we actually make a closed profile. I'm not including the gypsum wallboard in the tolerance because we want that to be finished on the inside, so that can, it doesn't really concern us. So I'm just going to leave that like that for the moment. So if I then run the window around it, we could take this out, and we have an idea that this is the cutout we want to take from the wall in order to make the tolerances and in order to make the chamfer at the edge here. So I'm just going to trim the edge here so it's nice and clean. So then what we do is I'm just going to select it, and I'm going to use copy to clipboard. And now I'm going to start a new profile family, because anything that runs along anywhere in Revit, you can make a profile out of this, for example, and get it to run along or whatever. So I'm going to make a new profile. I'm going to make a new family, and go into the English setup and go to metric profile and press open. And now we can go and paste in the profile we've just made, like that. Okay. Everybody with me so far? No answer. All right, so then I'm going to select it. I'm just going to move it right up into the corner here, so we know it's going to insert at the exact position. So I'm going to save it, save as family, and I'm just going to put it on the desktop, and I'm going to call it chamfer profile. Good. So now we made the profile. We can load it into the project, and now it's in the project, and we can use it wherever we want. Okay. So what I want to do is take a byte out of the top, a byte out of the bottom, and a byte out of the two sides of the panel, so that we get that effective profile going on. And the way to do that is to go into architecture, and we can use a reveal. And we get horizontal, vertical, or whatever. So I'm going to go over here and say, edit the reveal type, duplicate it, and I'm going to call it edge reveal. And now we can use the profile we've just made, the chamfer profile. Okay, and we can put one at the top. We can put one at the, I need to press it every time actually, wall reveal. We can put a vertical one at the side. Oh, that one's backwards, but never mind. So we got two of them in that come in nicely like that. And when we put it in the next two, they're going to come in backwards. So I'm just going to show you how you switch that then. So I'm going to put wall reveal. I'm going to put this one in at the edge here. And you can see that it's outside the element. So we need to go into the plan view, and we can go and find it, and then we can just switch it like that. So we get that byte taken out of the edge of the panel. And the last one I want to put one in at the bottom as well. Wall sweep, horizontal. I'm going to put it in the bottom. Oops. It's using the wrong one. Oh no, it's not sweep, sorry, it's a reveal I'm doing. Reveal. And once again, it's come in backwards, so we need to go into the section view. We can delete that pattern now, because it's done its job. We can come down here, select it, and then switch it so it takes the bytes. And you can see that in the section view, it's taken the 10mm tolerance out, it's taken the chamfer out, and it's, the plasterboard remains on the inside. Okay. So that's the first thing. Now, let's say we also want to build into our. If we go back and look at this PowerPoint here, well, not the PowerPoint, but this one here. If we look at this panel here, we've got some electrical channels put into the panel already. So we want them to be manufactured on the site as well. So I'm going to put those into the panel as well. Okay. So again, it's exactly the same process. I'm going to go and make a new family. I'm going to make a metric profile. And this time around, I'm just going to make a rectangular channel. Let's make it 100 millimeters, and let's make it 60 mil deep. And save as family. Put it on the desktop, and let's call it L channel. Load into the project. Okay. And we do the same thing again. Let's just go to the 3D view because it's easier. We've got that one sorted, and now we need to sort out this one. So I'm going to put in a reveal. Edit the type, duplicate it, and call L channel. And now we can change the profile to the new one we made, and we can just stick it in wherever we want it to be. We can always select it afterwards, and we can change the dimension of it. So let's say, okay, so 600 is fine, but we can just type in the dimension we want it to be at. So now we've got the cables running along the wall inside the panel we've just made. And the last thing I want to insert into the basic panel is we're just going to put a window in here. So I'm just going to take a window, and I'm just going to choose a random window just as an example. Let's just take something that's a little bit big, and I'm going to put it in here. Like that. Again, we can select it and change the dimensions to whatever we want to be. Let's change that to 600. So then we have kind of a basic panel set up as the basis for all our panels in the external wall. But we don't want to do that every single time for all the panels, so we need to automate the process in some kind of a way. So the easy way to do that is I'm going to select everything we've just made, and I'm going to go up here and I'm going to turn it into an assembly. I'm going to create assembly. You get a warning, don't worry about that. Now it's asking us what we want to name it, so I'm just going to call it prefab panel A, and it's under category of walls, and OK. So now if I run the cursor over it, you can see it selects everything as an assembly. OK. If I go to level 1, I'm going to change the scale to, let's say, 1 to 50, and turn the detail to fine. If I go and say, well, now I want to copy this, I can go and say copy from here to here. And what it's telling me is we've created a new assembly, but because it's exactly the same as the previous one, it's going to give it the same name. Okay. So you can see that if I turn the let's just turn it to 1 to 20 so we can see that in more detail. You can see that the tolerance is in here, but the gypsum board is automatically linking together as the finish. So you know, when you're going into your detail drawings, this is where you start to annotate and put in whatever joints need to go in there and so on. So we have something like this. The inside goes together, and the outside is something like that. Okay. If we get to a point in the room where we actually say, well, we have cables running along the floor, we want to bring them up and into this channel over here. It's the same process again. I can just go and say wall reveal. L channel is already selected, and I can just say, well, I'm going to put it vertically, and I'm going to put it here. And what Revit does is it creates a new assembly type. So if I open this over here, you can see now we've got prefab panel type A and prefab panel type B, because we've made modifications to one of them. So it's actually said, well, you need to make a new product for this. The factory needs to generate something else. So we can go and then select this. If I can just grab it. And we can just stretch it down so that we don't need the channel going through the entire wall. So now we have type A and type B set up. Everybody with me so far? Never any answers in this class. Yes or no?
Yes.
Yes. All right. Okay, now that's all fine, and that's nice and that's helpful, and then we can copy these, and then we have all these panels. But we also want to create a set of drawings of it, and we don't want to have to do them by hand because that would be just too last year. So what we can do is we can select panel A, for example. Well, which one's panel B? Which is the one with the channel on it? That's prefab panel B. Let's select prefab panel B. Well, we select it over here. Right click, and we have an option to create assembly views. If I select that, it's saying, well, what drawings do you want me to do for you? So let's just say, well, why not all of them? And we'll make them at 1 to 50. We can ask it to make, it's already going to make a material takeoff of the panel automatically, but we can ask it also to make a window schedule if we want, or a wall schedule. And we can add a sheet to it. I'm going to load a sheet because I don't like the Revit ones themselves. I'm going to load this one from here. And I'm just going to press OK. And if you watch over here, suddenly we have a load of different drawings have been generated without us having to do anything, which is nice. And then we can go in and just modify them and give them more detail. And we can, for example, say, where's the plan detail? We can grab the plan and put it in here. We can get the right elevation, put it in. We can get the left elevation, put it in. And we can get a detail section and put it in. So then we can start to play with how we're going to arrange this stuff on the plan. So let's say we're going to just rotate it so it all relates. So let's rotate it counterclockwise. So that relates to the position of the plan. That. This one I'm going to rotate the other way. Like that. And let's just take everything and move it up like this. And of course we can go in and you know, change the detail levels in here, fine detail for example, and we can go and modify all these lines. We can split the lines so they're not so chaotic on the sheet, and play with a certain amount of stuff, not everything, but a certain amount of stuff within these drawings. And of course we can add annotations to it as well. The other nice thing we can do is we can take the material takeoff, just drag it in, put it over here. Let's make it so that it's a little bit neater. Put it down there. And we can go and modify that as well. So I could double click on that and we can add, you know, whatever fields we want. Maybe we don't want meters cubed, we want you know, area of meters, or we want, I don't know, what else would we need in there? Material thickness or something. Doesn't give us that option. We could put in cost, and so on. So that's sheet A1. And we can also go in and let's just change elevation right to something that makes more sense. So let's just rename it to internal elevation. I'm always doing that. And elevation left, we'll rename that to external elevation. We also have a 3D orthogonal view we can put in, and they just give you one to start with, but you know, you can use that for several things as well. So that's like a basic component drawing that's set up. Let's just give it the correct number. So it's to do with walls, so we'll make it 21. It's a component drawing, so we'll make it 4, and we'll just make it 0, 0, 1. Okay. Now that we've done that, let's go back into the internal elevation. This is where you start to actually annotate and, you know, make some detailed dimensioning as a component drawing, dependent on the method of procurement you're talking about, as to whether it's going to be made completely in one factory or it's going to be, you know, farmed out in different factories or whatever. It depends on how you set up these component drawings. But what you should really do as well is you give a overall dimension like this, but you should also give a dimension to the tolerances on the edge, and you could dot those lines in. So you could just, you know, either, well, I would just use actually a detail line and make it a hidden line, and I would put the tolerance in here, you know, and give it a dimension and so forth, and call it out as a tolerance. Because if we go back in here, you can see that these dotted lines here are actually to do with the tolerances of how things are put together. And it's one of the main things that they talk about here, for example, in the interfaces between elements. So we have some elements here, and in this case the concrete elements have been made separately to the windows. So they need to consider what is the tolerance between the different products in the manufacturer. Okay, So it's something you really need to consider in your component drawings and call it up, because it's something the students always forget. You get extra brownie points if you start talking about tolerances all the time. So anyway, get back to this. So you can continue to add details in the usual way with annotations and so on to the sheet here. The other nice thing we can do if we go into this section is we can also take a call out, view call out, from the top here, and then we can make a new sheet. Let's make two call outs actually. Let's make a call out from here and from here. We can go and right click on the panel thing, create assembly views, this time check none and say we just want a sheet, and it automatically renumbers the sheet for us down here. But now we have detail set up, which we can change the scale. Let's say we wanted to go into complete detail, the 1:10, and we can put in the one for the top and we can put in the one for the bottom. Change that to 1:10, and this is where we can start doing some decent old style 2D animations, or not animations but annotations. Don't start doing animations, I didn't say that. Just going to switch those crop regions off. But the benefit of that is that once we do that, the drawing number is then shown up on the previous. So the interrelation between all the drawings is then it's together. All right. There's one other thing I'm going to show you with the assembly drawings before I take a break, and that's to do with just the quality of the image that you make. If we go into this orthogonal image, the usual Revit setup has this kind of very blank computerized looking view, but we can change that. We can go over to the graphic display here, and under graphic display we've got something called silhouettes. And silhouettes are what we used to do by hand, is that every time you came to the edge of an element like that, we used to draw it in a thick line, just because graphically it pops out of the sheet at you, so it doesn't look so boring and robotic. So I'm going to change the silhouettes to medium lines and apply. So it immediately, you can see that it pops everything that's in 3 dimensions out of the sheet, and it makes it much more graphically easier to understand, if I can speak English. The other thing we can do is, we don't want to cast shadows, but we can show ambient shadows within the 3D drawing as well, and that gives you a little bit more 3D within your sheet as well. So just anything to make drawings easier to understand, easier to conceptualize for anybody who has to actually build them, is always a good thing, because all this just makes everybody's life easier, and therefore less subject to mistakes and so on. Okay, so that's the first part. So that's how you set up very quickly a component drawing from a simple 3D model. I'm going to get a cup of coffee, and then I'll show you how to then schedule all your assemblies within your project so that everything then hooks up together. All right. Any questions about that so far? Okay, now tolerances. I don't know, has anybody ever talked to you about tolerances before? Yeah. So you know this website? Yeah. Okay, fine. So I won't talk about that anymore. You use that? Okay, fine. Right. So so we got the basic setup here. I mean, I would go in and change these patterns, these hash patterns and so on, and yeah, play with the detail and so on, and get all those things functioning correctly. But we could also go in, for example, and add a windowsill as a separate component, or an internal window board or whatever. You can add all that to your assembly as well. Let's save the project. What do we call it? 4J Assemblies. So the nice thing about assemblies, if I just wait for it to save here, I'm going to close down these, or close up those drawings there. If I go and put in another prefab panel B, for example, if I go and drag it in like this and I put it here, it'll say edits cause an assembly to match an existing assembly type and inherit a new name. So what it's saying is that it's because this is exactly the same as this, it's given it the same name. If I come to a point in the building where I want to put a ventilation opening, let's say, for example, in the wall here, it really is as simple as just saying, well, I'm going to put a wall opening in like this, and just in the usual way. Of course, you need to measure it. But as soon as I do something to it, it says edits cause a new assembly type to be created, and over here it's created a new one, type C. So it automatically updates so that you have the right number of products. So you don't have to worry about the number of products as long as you get the system working correctly. So now we have 3 assembly types in the project, each one of which we can create assembly views for, and take it further as quickly as we possibly can. So that's one thing. The next thing we need to do is, back in the main project, we have the plan that looks something like this. We need to be able to tag all these and schedule them. The scheduling part is simple as going into schedules and quantities, right click and say new schedule, and we actually have an option here for assembly, so we can just select that and press OK. And then we can add all the different stuff. There's a lot of CCS stuff, but we don't use that on the international line. Only on the Danish line they use that. But we can put in count, so that's how many there are going to be. We can put in description. I'm going to put in a model. And I'm going to put in mark. And press OK. And at the moment it's pretty blank because we haven't put in any information regarding the assembly. So I'm going to go back in here, and I'm going to select this type here, prefab panel type B, and I'm going to edit it. And in here we can actually type in information we want. So I'm going to give it a model number. I'm just going to assume I'm the factory guy, and I'm going to call it PP for prefab panel 001. Simple as as it would be. Press OK. Oh no, we can also give it a description. So let's call it panel with window and horizontal and vertical electric. Let's just say L channel. And press apply and OK. So now when I go back into the schedules, assembly schedule, all that information is turned up in the schedule here. Now we can modify that in the fields tool here. Let's say I actually want to have the model type at the top and over on the left here, so I'm going to move it up to the top here. The description is fine. Let's put the count at the end, and we also want to sort it by model type first. Give it a header, and we want it to calculate grand totals, but we don't want it to tell us about every single one of them. Press OK. So now it's got one of these, and it's got 2 that we haven't given a number for it yet. Okay, so let's go back in, and this one was type B. That's the one we did. So let's change type A. In here we're going to give it a model number PP 002. Very complicated numbering system I have. And then we can give it a description as well. Panel horizontal channel, etc., etc. Apply. Okay, if we go back to the schedule, then there we have this one here. So you can add parameters to all these products, and then it'll automatically schedule them for you and calculate the total of them as well. So that's one thing. So that's very useful. And the other thing is, when we're making an assembly plan on site, which is, if I go back to this thing here, we want to make something that looks like if I can find it, like this, because this is telling us the product number and where it is on the plan. So in order to do that, let's go back into Revit. We need an assembly tag. They don't have one automatically loaded in Revit, so we need to go and insert it. So insert, I'm going to type assembly tag. There's one there. Just going to select it and download it. Now I'm going to open it up. And it's only got this one T in it. So the label is very simple, but we can modify that. So I'm going to select the label and edit it. And now we can decide that we want to put in the model number. And we can leave the type mark, but I'm going to move it down. A type mark is something you type in yourself. So let's say you want to have a numbering system for the different panels. They might be the same model, but you need to know which one goes when. That's what you put in there. So you know, with your own two hands have to type that in. It won't do it for you. Okay. So I press OK, and then I'm going to load it into the project. Assemblies. Okay. So now, if I run the cursor over the assembly, you can see that a little tag appears based on the type of assembly it is. And we can also modify what that looks like as well. Let's just select it and we can change it to a standard one without a box around it, because, you know, the simpler the better. Let's make it 1 to 50 like a normal drawing. And basically that's it. So then you have a way of locating your panels in the project, and you have a way of generating a detailed component drawing from them. Don't think I've got anything else to say about that. Any questions? Yeah.
So if we, for example, make a component drawing, it should only be one element.
Yeah.
Even though there is a lot of elements.
It depends on the process. Like if you're making, if you're getting a precast concrete elements made, and then you're going to put some, you're going to hang some bricks on them, for example, but that's coming afterwards with the brick layer. Then you would only make the component of the concrete element, because that's the bit that you want to get made. Yeah. In this case here, I'm assuming we're going to get the whole panel with insulation and everything made in a factory. But it's you really have to think about what's the procurement method first of all, and then you can make the.
So if it's concrete floor,
yeah.
The prefab elements, you take one element, and for example, if there's ventilation ducts running through, it's only one element that is specified.
Yeah, exactly. If you're going to put that level of detail into the concrete element, then you can do that quite easily. Yeah. There are some limitations. I mean, if you go into the help file here and go into assemblies. All these elements are not allowed to be included in assemblies, like things like curtain walls, groups, you know, some types of railings and so on. There are some limitations on it, so you kind of need to play with it and figure out what you can use it for and what you can't use it for. If you were doing a curtain wall, for example, you probably wouldn't put it in an assembly because it's already a type of assembly. You would just take it out as a curtain wall, you know, on the window schedule or something like that. All right. So that's it.